Okay, hello everyone. Thank you for joining today's webinar here on SimScale with Jeroen Janssen, Associate Director of Thornton Massetti, and Joel Lopez, who's a computational design specialist and architect at Link Architecture. I'm very pleased to have both of you with me today. And today's session, we're talking about the simulation for buildings and cities and what's the latest in the Rhino and Grasshopper ecosystem. So yeah, we're up to date about new developments, new tools that are just upcoming, and yeah, simply get up to speed and talk about recent projects where maybe new methods, new tools have been useful. We're waiting for another couple minutes before we actually start. Until then, I want to make some technical remarks. If you have technical issues, please write in the chat and we'll try to sort it out as soon as possible. Also, please, throughout the whole session, don't hesitate to directly post questions. There's a questions feature in the GoToWebinar software. Use it, post a question, and we'll take 10-15 minutes in the end to actually try to answer all of your questions. Okay, so then let's start. Again, today with me, I have Jeroen Janssen, Associate Director at Thornton Massetti. Hello, Jeroen. Nice to have you here. And I have Joel Lopez, Computational Design Specialist and Architect at Link Architecture. So without further ado, let's start. The topic of today is simulation for buildings and cities, the latest in Rhino and Grasshopper ecosystem. Yeah, so before we go into all the details and the fancy new tools and methods that we developed, let's take a look at the agenda. A very simple framework today. Quickly, let's introduce SimScale so everyone is up to speed who we are. If you're coming from the Rhino ecosystem, so you understand why I'm talking here. And then some of the latest news on the SimScale side, and then I'll hand over to Jeroen for introducing Thornton Massetti and how he's been using recently, or they have been using Rhino and what's new in their tool stack in the AC ecosystem. And then Joel will take over from Link Architecture to introduce himself and his use of advanced computational tools in the projects that are done within Link Architecture. And in the end, we'll have a short roundtable moderated by my colleague Nagman Khan, who's talking about some of the new and important topics in AEC, and we'll take a few minutes towards the end to answer all your questions. Okay, so yeah, quick, what is SimScale? Who are we? SimScale is a cloud-native simulation tool. We have meanwhile 600,000 users worldwide, accumulated over the last 12 years in existence. We have customers in more than 50 countries and still add more than 10,000 users each month. And yeah, meanwhile grew to about 130 employees around the globe. What is SimScale in detail, right? Besides being cloud native, we're a platform that enables many physics, structural flow phenomena, heat. We'll see that later as well in the different examples, and much more, even as far as electromagnetics. And this is all delivered in a single user interface, and that's, I think, what makes SimScale unique, that you can do a vast range of different physics in the same user interface. It's cloud native, that means we have all the computational power at hand, right? There's no installation, just a login, and you have a cloud app, a browser app that runs in basically any browser. We can simply log in and start simulating. What's also very special is real-time collaboration. I think in the AC world, meanwhile, that's the standard, that all the tools you're using are collaborative by nature. And that's also what we think is a core in the future of simulation, as well as we also support customer support in the tool. So if you have any questions in your simulation setup, you don't know how to proceed, you can directly ask in our chat. You can share the project, right? There's no gigabytes of data to be sent around, just instant access to the project if you share it with support or any one of your colleagues. As said, that being cloud native means we can run simulations basically at any scale. We can run multiple simulations in parallel, all the different design scenarios, right? Summer, winter condition, any other conditions in a building context maybe, and explore the full design space. And yeah, more recently it's becoming more important to be AI ready, right? Have AI functionality that basically just helps users to be more efficient with their work, maybe enable new kinds of insights that weren't available before. And that's also at the core of our platform, that we are AI powered in different stages of your workflows. Okay, that's enough about SimScale. What is also maybe bringing us towards the topic today, while we are talking about SimScale and Rhino and the Grasshopper environment. SimScale enables connectivity with the SimScale API, so you can integrate functionality from SimScale through a programming interface and call it from wherever you want. And this is how we developed multiple integrations, or our customers or partners have developed integrations in multiple tools. So the classic is integration in Rhino and Grasshopper. We'll see a bit of this today. It's very known in the industry, right, to connect from Grasshopper to any given tool that enables an API connection. As well, in the middle, NVIDIA Omniverse, right, we have a plugin in the Omniverse to enable data transfer from and to Omniverse, and also, another example, GIS integrations with Esri to have a bit another view on simulation data from different stakeholders, right? Maybe later in the process, in the development, or the master planning, maybe as well, integrate with tools that are used at the specific stages of each project. So that's it on this general level. Now, a quick update what has been recently made available or is soon publicly available. We updated our plugin for Grasshopper for microclimate and UDCI calculation. A few of you that have been using SimScale in the past know that we have a Grasshopper plugin available that runs in Grasshopper and is basically automating microclimate assessment. It's running the heavy lifting analysis on SimScale, like the pedestrian wind comfort or the individual wind studies, and the additional post-processing like the solar radiation studies and the combination for the UTCI assessment in Grasshopper. And we had this since a long time. Now we finally updated it into a new version. It will be available on our general GitHub page, where we have all our public contributions available. The news about the new plugin is that it's now a native Grasshopper plugin, right? It's written in C#. It's a native plugin. No need to install different Python versions, libraries. No need anymore to have any admin privileges, right? That's a big problem in large organizations, that typical users don't have admin rights on any computer. So that's not needed anymore, and it's compatible also with Rhino 7 and Rhino 8, right? That will be really important now that everyone is moving to Rhino 8, if not already moved on a long time ago. And also the quality of the plots and the mesh is now much better than before. So this is still an ongoing project. We will release it anytime soon, and then be on par with the previous functionality, just easier to use. a bit better quality, and then at the second stage we'll basically improve that also for multi-season assessment, so you can have the analysis of UTCI on a range of hours throughout the year, compute averages, exceedance, times, and percentages, and much more. And the other new topic which I wanted to share with you today is a Grasshopper plugin that is developed by our partner Beyond Carbon, and they develop a Grasshopper plugin for thermal bridging, for 3D thermal bridging. Some of you might know that thermal bridges are important, right? In these days where we isolate our buildings a lot better than before, and we need to take more care about certain features in the building design that might act as a thermal bridge and pose problems in later stages, right, where we have condensation issues, where we have mold growing, or simply just lose heat throughout the facade where we shouldn't lose any. And yeah, there's software available for 3D. It's a bit limited what is there, especially from within the Rhino ecosystem. So that's why Beyond Carbon decided they built it themselves with the help of SimScale as the backend, and to provide support for the API integration. But they did all the work themselves to on the Rhino side to actually have an automated workflow that in the end goes as far as actually building a report from the whole 3D thermal bridging analysis. So yeah, we see here schematically the process on the right. It looks like a very complex process, right? If you zoom out, but in the end, it's a rather straightforward analysis. Let's put it like this, although there are many different things to be considered, and also specifically on the output side, right? There's very specific values that are needed for a proper thermal bridging report, right? You need the chi value, the U values, and so forth for all the different wall segments and points. And this is done with the script all in one. Right, so it takes the original Rhino geometry, applies all the conditions there, and it pushes the case to SimScale where it's then solved. And then it gets the results back into Rhino, right, for the heat flow results, the surface temperatures, and so forth. Saves it as CSV, and then visualize that in Rhino again with the specific 3D thermal bridging properties like the chi or psi values that are relevant here. So this is now already there. You can see it on the top right, a typical report that is generated with the help of exactly this plugin. It's currently also not released. The plan is to actually release it to everyone that is interested in using it, and maybe also taking part in the develop it further. It can generate reports, right? It can visualize the temperature distribution on the geometry directly within Rhino, within your typical visualization tool chains as well. Yeah, so shout out again to Beyond Carbon, who developed this tool, right, with SimScale as the backend for the computation, and Rhino Grasshopper for the whole interaction and the front end with the user interface. Okay, and that's it from my side for now. At this point, I'll hand over to Jeroen, who can then show us a bit what is the latest and greatest on Thunder Mercedes side for the use of Grasshopper and Rhino.
Sure, thank you.
Up to you.
Thanks for having me, first of all. Let me bring up the presentation here. So thanks for having me on this panel. Always great to be here in good company. I thought I'll just give a little bit of just a one-slide overview of Thunder Mercedes. We're engineers involved in buildings of all scale, super tall, stadiums, but also the more special sculptural, like up to the master plans and the large scale. And that's also a little bit what I want to show you today. I'll jump a little bit about scales, as you'll see. And I'm part of what we call Core Studio. So Core Studio is our innovation and R&D team. And roughly speaking, we can divide ourselves into kind of 3 big buckets. Core modeling on the right-hand side, so very actively involved in projects, head down and actually working with teams, working with larger design teams on actually delivering buildings, master plans, etc. But then on the other side, we also have core application development and AI. So actually looking at apps, plugins, and workflows, and how can we actually push not just our firm internally, but really the whole industry forward. And of course, that's the core AI in the middle, really pushing it to the next level. We're quite a large team internationally, so we're spread out throughout the whole firm globally. I'm sitting in London. There's as well a big chunk in New York, as well as spread out throughout the other firms, the other locations. And what I want to show you today is basically some of the, really talking about apps actually. So almost like leaving Rhino and Grasshopper, which are our daily tools, and they're amazing 3D geometry tools, but taking them to the next step, actually building on top of that framework of Rhino, the whole plugin environment, and what can we do more? How can we actually push the things forward? So this is just a big board of all the stuff we have been doing, and I'll just zoom in on a few little things. And really, Rhino and Grasshopper are in the back end of all of that, and that's often where our journey starts, but then also where the tools come back into. So one of the tools I wanted to show you is this is very much in development at the moment, and I'll have a link in the back where you can try it yourself. It's called Force Sketch. So the idea with Force Sketch is to basically be a very early design stage, and it's a web app, so you can use it on your computer, but also on your tablet, on your phone, etc. And it's a sketching platform with some Rhino and Grasshopper compute in the background. It basically solves through Karamba, which is a well-known structural engineering plugin within Grasshopper, and then actually gives analysis results back on the sketch. And it's really thought of as this early stage sketching tool. So any structural engineer in a meeting could basically pull up their sketchbook, start drawing and analyze it. And it actually has like proper kind of eye sections, square sections in there. So this is the interface, and I'll just talk a little bit over this. But really, as you say, you draw your structural diagram, put some support and release conditions up there, loading, and then you can basically very easily copy paste and, for instance, change the support conditions or add some braces. And then when you actually press run, it then talks to the backend, calculates, and gives you the analysis back. And this is really how we think we can actually bring the whole Grasshopper compute, etc., to the next level. And it becomes an interactive little tool. Similar to that, I won't hang too long on this, but you could basically load in, say, a plan of an architect and actually start, or a section, and start drawing over it. So it has concept about gravity, etc. Essentially 2D, but yeah, that doesn't limit much. You can try it now. We actually have a couple of little games out there to try and kind of optimize a tower with the least weight and stuff like that. So that's hot off the press. Another tool I want to talk to you about, and that's the one I've been involved in quite a bit over the last, I think it's now 2 or 3 years. It's a Nuada CFD, so it's your virtual wind tunnel in Rhino. So this is bringing SimScale into Rhino. So SimScale is great, and being a web platform and all of that, it's very easy to use user interface, but it's still disconnected from our 3D model. So we started on this journey, and as I said in the beginning, a lot of what we do is about workflows and making it easier to work with that. So this is a Rhino app. So it loads in your Rhino model. So you have your model in the background and a couple of layers set up with your building, and then it basically with a few clicks in those screens, you can set up a simulation. So either pedestrian comfort or a single direction, looking at facade pressures. That then gets built. It is being pushed up to SimScale, runs in the background, but you as a user, you don't have to leave Rhino. Actually, it computes on the cloud, and then when it's done in this same window, you can then actually bring the results back into Rhino and visualize, in this case, pedestrian comfort around this tower. So for instance, we looked at typically like your 1.5 meter high plot around this building, plus the roof terraces as you see there. And then you can see about effects of the wind really hitting this tower, downdraft, and creating those uncomfortable conditions on the ground. And then, so this was already competition states. Then you can actually start molding the geometry and do some more runs and actually look at the effects. Similarly, you can actually look at a single direction. So this is wind coming from, I can't remember how this is oriented, to the windrows, probably from the east. So looking at the effects of actually one direction. And really what that allows us to do is to look at quite varied projects, let's say. So from some very complex geometrical urban environment with all kind of canopies and stuff, which in Rhino, that's your natural day-to-day workplace, but in other analysis software, sometimes that might be a bit more tricky, to like looking at facade pressures on a building. Or this was a fun one. I gotta admit, this was not through Nuada. This is actually SimScale, but it connects to Rhino. It's looking at a set of metal spires, and the question was really as, will it whistle? So we run some CFD analysis on that, compare that with our acoustic specialists. Or very large master plans, right? So you can actually, so what we're looking at here is, I think it's 2.5 by 1.1 kilometer master plan, and actually start again, being in Rhino, manipulating the geometry and actually optimizing for pedestrian comfort in this case. Again, you can try it. We love the QR codes. So Nuada is available through the Rhino package manager. All you then need is a SimScale sign up, but yeah, I'm leaving that out here. But then you can try it for yourself. So you'll find the information on this link. And then I wanted to, but I might whiz through in the being conscious of time. I wanted to show you some of the AI applications that we've been doing over the year. And really our bigger question here is like, how can we actually give all of that knowledge of a global firm into everyone's hands right from the beginning of a project and throughout all of the scales, from basically your most experienced directors give their knowledge into the hands of the junior that started last week almost. And for that, we developed a set of, again, it's about workflows, but a couple of engines which really come down to 3 buckets: data, machine learning itself, and MLOps. And I'll go into detail what that actually means. But starting from data, it's our past projects, right? So we got a lot of engineering done. But actually what we've noticed is that's all very, very messy, like whether it's analysis models, 3D models in Rhino or Revit or whatever, up to drawings if you go even older, right? So what we've actually started doing is generating synthetic data. So analyze 100,000 columns, analyze 200,000 beams, and from that actually generate data sets. but that takes a lot of time and effort and compute, right? But nowadays we can bring those decades of analysis and knowledge to days on a computer. Number two is the machine learning in itself. So we're really going for small apps that do little things but very well. We have a team of what's called Core AI of 4 or 5 people that are actually day-to-day working on machine learning. However, not everyone, if you want to use this into the wider firm, not everyone is a Python expert, is a machine learning expert. And not everyone can tinker with those parameters and further details of those models. So basically what it comes down to is like from the traditional design, we want to basically gain that 50% performance. And for that, really what we need is that third bucket, MLOps. So really learning from the software development. You need this continuous stream. You need somewhere that hosts these models, etc. And that's what Cortex does for us. So we build a platform in the back end. No one has to interfere with it except for the core AI team, the machine learning experts. So they put their model up there and they can tweak with the parameters and tinker, etc. But then what Cortex allows them to do is to generate an API token. And that then allows everyone to either build an app, whether that's in Swarm, Shapediver, Python, in the browser, in Grasshopper, and with that app or API key, actually start using it. So that's what Core has been doing recently a lot. Actually, I got to zoom back a little bit, all the way to 2018 when our journey with AI apps started. So we started off with this app Asterisk, and the idea was to look at qualitative early stage structural engineering. So put in a mass, and in this case a core, and then within a Rhino, it was a Rhino plugin, which then analyzed that, basically cookie cuts the whole building in terms of levels, structural base, put columns down, and then it was basically giving out very accurate structural sizes. So you could play, you see the sliders, you could play with the base sizing, and it would generate a new structural model, whether it's concrete or steel or timber, and it would give you actually the weight and the cost, etc. We quickly realized that actually became a big black box of options, and yeah, a lot of requests like visualization, color by attribute, color by section, etc. It really allowed us to look at various options and compare them quickly, but it also became a monster to maintain. And fast forward to today, what we're really doing now is actually breaking them down into smaller apps like this Truss Designer. So it's just a single truss. It's a web app in Shapediver with a few parameters, and it allows you to just run this quickly, but it has the same level of detail of results. And of course, now it's not necessarily black box anymore because of this truss. Any engineer could actually redraw that in their analysis software and compare one for one with the results they trust, which talking to structural engineers is a big thing, just to be able to verify that. But we've trained that with 50,000 trusses, tested it at 10,000, and yeah, it's actually spot on in terms of validation. Similarly, we looked at shear walls. So every building, especially tall buildings, you got to design your shear wall, your core wall that takes your wind load down from a horizontal load down into the foundations. So we've basically analyzed 80 million of them, and that ended up into one app where you can then, it's actually very detailed. You can give it number of stories and height, etc. But you can also play with like reinforcement rates that you want if you want to go into that detail. But you'll have a results where maybe analyzing one of these walls takes half an hour or an hour. Now it's milliseconds, and you can just run through options so super quick, which is amazing. Another example, I'm just whizzing through these, but another example is a timber column stack, so 5-6 stories, and then get the section sizes very quickly with just a few parameters. So you set your load and you get a size up. And these are all web apps. Another one is Steel Bay. But what that also allows us, which is that Shapediver has a little API, so we can actually bring these back full circle as a little component in Grasshopper. So it's a Grasshopper component running in the cloud. So that's the essence of Shapediver. Talking to Cortex, so that platform, that MLOps platform that I mentioned, giving us a result of a section size, and then the app visualizes it. Or we can bring this back as a little app, as a plugin into Grasshopper, and actually start daisy chaining them together into bigger projects. Yeah, we've seen enough, and that led us then to, this is that daisy chaining, to actually connect multiple together. So we're still thinking about Asterisk, but this is now Asterisk 2.0, which does a whole building, steel, concrete, timber, with a couple of sliders, and it allows us to also look at other integrations. So we're working together with Schema. Schema is a platform that, again, a web platform very similar to SimScale and Interface, but it's an early stage massing generator and designer. And we've integrated the Asterisk 2.0 into the Schema. So you'll see enable steel frame was just ticked on. From that massing, it basically generates an entire steel frame of that apartment building within seconds, which in the background talks to our Cortex model, which then gets stuff back into here. So it really allows us to go that next step. Furthermore, I'm going to whiz through, but we're thinking about generative AI, like similar to you do your prompt and you get an image back. How could that work for structural engineering? So basically get some load spans and ratios out and get ABC designs proposed by an AI app. So in this case, get some properties on the right-hand side, but the app now generates 10 potential sections. And you could say, oh, I want a shallower one, I want a deep one, and start thinking about all that sort of stuff very early design stage. I'm not going to talk too much but yeah, it allows us to do all of these stuff like shear connection and bolts and stuff, very detailed stuff, but at scale for the entire building. And then I do want to bring it back to, as a final slide, to the more large-scale climatic modeling. So we've been playing with the same Cortex interface, machine learning, but now on airflow around buildings. So we've been, this is a very early stage prototype with the folks at Kojima in Japan. So we collaborated with them to get full-scale large eddy simulation, CFD simulations done. But then they've trained an ML model, machine learning model on that. And that allows us, and then we wrote a little Rhino plugin to basically, we're looking at it in real time, right? So you change your massing, you basically scale up your building by, I don't know, 40 meters, 50 meters. You press run again, and you have, within 2 seconds, you have an updated airflow model right here. As I said, this is hot off the press and brand new. We're still tweaking with things, so want to put some legends and what do the colors actually mean and stuff, keep consistent colors, etc. But yeah, that's kind of, I whizzed through it quickly, but that's where we're at and how we try to push Rhino to the next level, really, with all sorts of scales of building modeling. And with that, I think I should hand it over to Joel. Thank you very much.
Great, thank you, Jeroen. Very interesting. Super cool.
Thank you.
Yes. Here we go. So, can you see my screen now? Yes.
Yes. Yeah.
Yes.
Perfect.
Oh, good.
But thank you very much for the invitation, and also Jerome for the previous presentation. Super knowledgeable and interesting. And I would like to talk a little bit on the architecture side on this presentation with Link Architecture and how we take our journey into studying outdoor comfort from the beginning of the project until the delivery. So I will start with a very encouraging headline, a project where you can sit both inside and outside all year round. And this is exactly what we talked about in the Åsane project in Bergen, the second biggest city in Norway. And this is a very big promise in Scandinavia and something very important for us as architects and also for our users and clients. So this is how it started in a late release on this project, where we described how we wanted to build from a busy district into a green, urban, and vibrant new part of the city with 300 new homes and 86,000 square meters. So a really big new hub into the Norwegian city of Bergen. And how key it was to really work with outdoor comfort, because this is one of the added values that in the architectural side we were working towards. And this is what also set aside a project like us in this scale as well. So today I would like to show you this journey on how we really study outdoor comfort in a project from the beginning until the end, using the Rhino Grasshopper ecosystem, SimScale, and also the expertise that we have gathered on these topics. So for my case, I would like to share a little bit on the agenda, 3 points. I would like to talk about our process of outdoor comfort first, how we usually approach this sort of problems, and then a little bit of a dive down on Rhino and Grasshopper for computational fluid dynamics, how we really work with it in the modeling side until we get some results. And then finally, and maybe most importantly, how to make it matter, how we really are able to share this knowledge within the design team, company-wise, and also to the outside world. So a quick run through of who we are. Link Architecture, as one of the biggest architecture firms in Scandinavia, in the 3 countries, Sweden, Denmark, Norway, 15 cities and 500 employees. And within Link Architecture, there is the digital innovation hub and digital network, Link.io, where our core members work digitally in collaboration to enable the dissemination of the development that we do within the team inside the projects. So we have developed a working method that we call the augmented architect, that we like to think of like Iron Man's helmet, that is giving you information as soon as you start your sketching tasks on the environment around and what you should know. So again, the augmented architect is trying to make a better connection within the physical conditions of the place and our digital models and our project ideas. So we reinforce our architecture with these additional layers, and that's why we call it the augmented architect. And within the tech stack that we have to make to build up the augmented architect, we have a few of the options that we're going to talk about here. We have Rhino and Grasshopper as a key part of our modeling capabilities within BIM and CAD, for example. The Link EP framework, that is the one that is uniting everything into a platform that an architect can use while sketching. And then we also have our analysis software. And here we can see where SimScale is placed to work with wind analysis, thermal comfort, and being part of our tech stack for analysis software. So again, this Rhino and Grasshopper environment is helping us to organize everything within our Link EP framework into the work that architects will take in their everyday work, and also how computational designers and engineers within the team will help to move the studies further. And this Rhino environment is the one that is helping us to put everything sort of in a manageable box that we call Building Sketcher. And this Rhino and Grasshopper environment is helping us to analyze all of these 12 factors where wind can be seen in one of them. Again, this Link PM Building Sketcher platform is built on Rhino with a Grasshopper backend and multiple connections in the tech stack, but is also trying to lower the bar as much as we can for our architects to use confidently just within Rhino and a human UI interface. So trying to lower the knowledge bar that you need in order to start sketching with the augmented architect. And when we think about the project timeline, we are always trying to work as soon as we can during the early phase with architects. And as we move along the detailing phases, we can see that wind is present all in this timeline, ideally from the start until the documentation and project delivery. So our process in outdoor comfort, we have talked in a previous SimScale webinar more in detail on all the steps that we take into the outdoor comfort, but to give a good idea, here we have the steps that we start. First, understanding the Scandinavian context and how we work to create urban comfort here. And then starting to get to know the weather data, build up a climate strategy, and then testing and iterating through our models within a Rhino Grasshopper environment. So for starters, on Scandinavia, our mission most of the time is to protect from cold winds. And this big vision is to extend the summer, this big promise that we work very hard to achieve with this type of studies. And luckily, our tools are the strategies for wind protection that we have developed as well. And now in previous webinars, but we can have a breeze through it here. Because we understand that for certain cases, there is a high importance of studying wind. And in the case of Ashanebergen, we were sort of introducing buildings of another scale within what it exists today. So therefore, the study of this was relevant, right? And then we already know which are the sort of effects that we can expect from a freestanding building with some funnels, or a rundon effect from a high-rise building as we have. So we already sort of can have an idea of what we will need to work with. And really starting the process, getting to know our weather data, we try to assess general conditions, the wind data itself with the wind rose directions, and also other comfort variables. So there's a blog post where we go deeper into this. But in the case of the project in Osan, even though we have different sources and we always compare, even within the same source, we can have different inputs of data, and then we need to try to decide which is the best. So for example, here we have 4 wind roses that are in different distances to where the project was located, and our work was to figure out which is the one that would really make sense for our environment, our topography, and also how the valleys of the Norwegian topography can work with wind. So what we did at the end, it was taking the third one, the closest one to the side, and rotating it slightly to make to account for this difference on topography that we have from where we have our weather station to our final site. Then as a second step, a climate strategy is very important, both in terms of wind to protect and slow down wind speeds, and also on the UTCI to try to mitigate cold stress, but also in a future-proofing perspective, because you need to start thinking about how climate change is really going to affect our projects and how we are calculating to account into these more extreme scenarios, either with higher and lower points on temperature, speeds, and frequencies. So of course, the IPCC scenarios are some great help to try to really account for this in our daily work. And then finally, we arrive to the point where we can start testing and iterating. So in our sketching tool, which is Rhino and Grasshopper, or with some input from a CAD or BIM software, we can start talking about geometry preparation and how we use this environment for CFD until the point when we reach some results. So the dive down on Rhino and Grasshopper really is on how we use this tool on a daily basis to prepare our models and to make sense of all the geometry and inputs that we get. So when we work with terrain, that is one of the most important parts of our model. We have developed a few workflows, as the one that I'm showing here with a mesh patch for a Grasshopper that is trying to project the available terrain that we have. Sometimes that can be a little bit limited, for an adequate size of a wind tunnel, something similar than what the Gizmo plugin does, but maybe skipping a few steps. So already having something good enough, so our wind tunnel can be well sized and accurate in that sense. Then we also have some workflows to import, for example, a terrain from a point cloud and then work it all the way until getting a nice Delaunay mesh within Grasshopper. Or some other examples as the detailing of a region of interest that we have from my colleague Matthias that has worked on this component, and a mesh parser scripts that we have worked, again, all trying to get a better tool set for us to work more efficiently. And then also working with vegetation, that is an important part of our model, with custom developed workflows to match how our architects work in 2D and 3D, trying to turn blocks into trees automatically, projecting them, and then ending up with a workflow, a wind model helper, a script that is helping us to go through this. So here, for example, we have a script that is trying to generate the different heights on trees. So it actually looks more like nature itself. And then working with buildings, right, where we can have different details of levels of detail, right, depending if it's a context building or the project itself. So here I'm showing a little bit on what can be done with the shrink wrap tool that came almost 2 years ago, officially shipped 1 year ago in Rhino, and I think it can give quite good results, but maybe it's still a mesh that it can be optimized in terms of size, right? Especially when we are starting CFD afterwards. So a combination between the current options of shrink wrap and a sub D sharp edge would be the ideal option. So maybe for further development from the Rhino guys. When we try to go further on the simulation setup, we play with a good old friend of the computational designer, Excel, to just build up a stat file when, for example, we have data in different directions and we want to from 36 to 12 or 16, something really quick, and maybe also work with them dividing data for different seasons. So this is something that works well, since we get this data on CSV, we can work already as well here, and then take it in the next further to trigger a simulation with some preset we have done, sort of old school 2 years, 1 year ago, and also getting the results in the same way in Rhino natively through Grasshopper and Python until the Noada CFD plugin that our friend Jerome helped us to get our hands into, and that was a super big step in our workflow of just getting our results back into Rhino in a more straightforward way that everyone can do, not the CFD specialist, but also a project architect can just drag the results and apply them into their model in order to continue the early phase studies and do them in a better, more efficient way to make it matter again, right? Then the post-processing results, we can use, of course, the SimScale browser platform or maybe some Purview to really try and make sense of how all of this data that we're generating help us to impact or design an iterative process, right? And until the last part, how to make it matter and how to share the knowledge. Maybe this is a critical part, because when we have worked a lot to simulate and have accurate results, they need to make it hopefully into the design for meaningful differences and improvements. So again, if we go back to the project timeline, when we think about the early phase, and how we work with wind, this is maybe the best alternative. Start early and try to give feedback as soon as we can to the sketching process, and then move along as we go further into detailing. So again, the best alternative is to provide guidance and a model that a project architect can work with, compare scenarios, compare what was the existing situation, as we can see here on the project in Bergen, and take a look at what was the situation before and what it is that we're generating with the new project, right? And see and pinpoint where we can have improvements with a little bit of our guidance on outdoor comfort. All the way until full documentation in the case of this report that we did for the project, in order for the municipality to really understand all the defects that we're having and how we are addressing with our design and everything that gets part of in the results. Then below, from a further one step further from the report, is how we have used Speckle as an AEC collaboration tool, and also its 3D viewer in order to have an interface that is really easy to collaborate with, and then mostly everyone can use, when you have a link and then you have a model that you can browse through and maybe even comment or post questions in order to have better tools to collaborate again and to impact the design better in the earliest that we can as well. And again, 2 steps further than the report, we're really also trying to use this data to ease up them from design. And what we're trying to solve here, to answer, is this question: where should we place the cafe in this new development, right? So we're trying to do the computation between optimal sun hours, for example, within this development that we're having here. And also we have computed the wind comfort. So when we're taking this preferred let's say range of spaces, we can then put them together to really pinpoint where we could recommend outdoor dining, for example, a pergola or a restaurant, so people can sit outside. So this is a little bit how we take our journey of studying outdoor comfort in Asana from the start until the final delivery. And just as some short closing remarks on how we share the knowledge as well outside the office, and how to stay tuned with us. Again, our team has been a bit all over the place. We can see some of my colleagues here lecturing and researching at a few places, and some others also presenting. And here myself organizing some events with the Sweden Design Computing community. So here I leave you some links to stay tuned with us, with the SDCC, and also with the Link.io, because we're gonna try to be better at sharing a little bit all this knowledge that we're generating in this case. So this would be all from me. And again, thank you very much for the invitation to share what we're up to here.
Great, thank you, Joel. Very impressive. It's always great to see all the different kind of qualities you take into account, right? Until you have such a large scale development done. It was very, very insightful. Also nice to see you both collaborating without without me realizing that initially on similar tools, right? That actually Jeroen developed and Joel is using for real projects. This is awesome. Let me share my screen back, and then we can invite Nagman for the Q&A session.
Hi, Rickard. Can you hear me?
Yes, we can hear you.
Excellent. Thanks so much, Jeroen, and to Joel and Rickard for some super interesting presentations. I know we've all worked together over the years, but it's really good to see the advancements you guys make so quickly, right? And it's quite a rapidly developing field, right? Computational design, especially with recent advancements in AI. So it's fantastic to see that coming through. Rickard, I'm going to cluster the kind of questions into 2 groups. Okay, we have a few minutes for Q&A. So the first one will take on physical aspects, and the other one will take on computational aspects. So the first question, I guess, to all of you, on the physical side, you all talked about microclimate, right? Specifically wind comfort, and a bit about outdoor thermal comfort. And we know kind of solar shading analysis is, bread and butter, right, in early stage design. What about other types of climate issues that we're seeing around the world in the news so often? So flooding, wildfires, the more kind of catastrophic, God forbid, the issues that are becoming more frequent. How is that being factored into your future adaptation designs? What kind of interest or feedback are you getting from clients, and what kind of things are you doing or have you experimented with? I'll open it up to maybe Jerome, if you go first, and then we'll hand over to Joe and Ricard can comment.
Yeah, sure. So I think we're coming at it from two sides actually. One is our sustainability and resilience side of the business. So they really look at before the effect. So in design, specifically thinking about the resilience, like what first of all identify what are the potential. I think they talk about shocks and stresses of a system, let's say, so whether that be flooding or future climate of increasing temperatures, increasing storm events and wind, that type of thing, and also becoming more extreme, these things. So how can we brace ourselves for that? And on the back of that, the whole thinking about how to generate new power and like decarbonizing our systems. So for instance, I just showed one image of that big master plan of 2.5 kilometers. I just showed a pedestrian wind comfort image, but on that one, there was a coastal location. We've actually looked at flooding, and in an ironic way, actually the biggest stress there was actually drought. So looked at all of that. And then the other way we're actually looking at it is our forensics group. They come at the event after something happened, so after a fire happened or a tornado came over land, and then assess the damage and trying to really research what happened. And the two groups are actually really talking to each other and learning from each other, like from after the effect, like if the disaster did happen, how can we actually take that on board and design much better for that? And then the third one, actually, while talking about, I'm thinking about it, it's a bit more on the R&D side. It's actually generating and testing some kind of future, and Joel mentioned, alluded to that as well, actually generated future climate data sets, right? Because all of our simulations software will use like what is called a typical weather file, a typical year of data. And usually that's always been historical measured data, right, from the past 30, 40 years. But now actually that's not even enough anymore. We need to extrapolate to the future, like what does that do? But also what's the effect, and is that actually true, or do we need to run multiple scenarios?
Yeah, interesting. And Joel, how about you guys?
Correct. Thanks, Zero. And I think from our side is really thinking about sustainability from the beginning of the project. We as architects come at very early stages at the conception of how the whole of this holistic system that we generate as built environment works. And I think it also works in different scales, from the urban until the architectural and internal building, for example. But how we have really tried to approach it is when we think about the strategies, the sustainability strategies that we propose in the early phase, from a master urban plan until the architectural side, then it's really trying to think about which are sort of the climate scenarios that we would need to try to address. And most of the time they are related also to the sort of geography that we are working on projects, and how urban they are or how rural they are as well. So for example, something that we have been also developing is sort of a water analysis, so rain analysis, and how we can think of it in two ways. Let's say a geometrical side, where we can analyze the surface that we're generating, the landscaping that we're doing on a project, and seeing where the water would gather and how much volume we could hold there, right? So this is something that we are already trying to apply in a few projects, and then trying to take it one step further with what Jeroen talked about, trying to understand how the climate data that we have, and how we can try to future-proof it in the way of, let's say, a factor that we say, okay, right now we're seeing an increase of 3 times the amount of rain that we can get in a typical winter day comparing to what we used to get, right? Or we are getting the amount of rain of a year in a couple of hours, right? So then it's really try to work with the science real deep in, and I think the IPCC reports have been quite a lot of help. For example, when we have tried to look at this in the temperature side and also on the wind speed side, but I think there is quite much more to do for us to really be able to say, okay, we're future proofing this. Like, we are really in the verge of no one knows what is going to be out there, right? So I think trying to already think of a conceptual approach and then let's say quantitative approach into the strategies that we have put into motion, it's what we have tried to do in our projects so far.
Yeah, I think it's interesting. What I've noticed is when it comes to things like flooding, what fires, stuff like that, the kind of real estate prop tech industry is using that data a lot more, right? Obviously, because they've built assets already, right? And you have issues with obviously damage, insurability, all those, that business kind of things. And now it's filtering into the design stage because that data is not easy to use, right? And figuring out how to actually design around it, against it. It's kind of adaptation, which I think as a discipline we're getting better at, but hasn't always been the core focus, right? Adaptation. So interesting points from both of you. The last big grouping of questions, and then I'll hand over to Ricard at the same time, is around AI, right? So you both mentioned it. Ricard, you mentioned it. Ricard's been involved in deploying, the product manager for some of the AI features at SimScale as well. What you're experimenting, it's obvious, it's clear there's some benefits coming there. Joel, I like your the good old friend Excel and the spreadsheet still. Thank you for that. Where is in the next 12 to 18 months, right? Let's say short term, even although that's still a long time when it comes to AI features, right? Things move so rapidly. But how do you see AI developing in, let's say, 1 to 2 years from now? Where will we be? And with that, I'll hand back to Ricard as well to take those responses and wrap up. Thank you.
Thank you, Nachman. Yeah, that's a good question, right? Where will we be in 18, 24 months? I mean, if I would know, probably I would play Lotto. But I think it's going into one direction, and this is like going beyond maybe the hype phase of AI and trying to find the useful areas, right, where it's a tool in a tool stack that unlocks potential that couldn't be unlocked before, right? So as Jeroen showed, like very small widgets, apps, right, that could quickly give you an answer where previously it was just too hard, too complex to do something, and people just had to rely on their experience, right? And I think that is something where we generally will go into something that AI will be a tool that not only is like generative AI, whatever generates something from basically nothing, but it will capture the knowledge, right, of people, of firms, of workflows, right, in a way that we can just be more efficient, right? I think Jeroen's example is very good, that a newcomer in a firm could really be efficient from day one and somehow get the knowledge that someone that was 30 years in the firm has developed, right? And that I think that would be an ideal outcome if you get closer to that, right? That we can quickly build up on existing experience. And I think collaboration is another topic where AI can help, right, to bring different topics together, different fields, right? Climatology, weather prediction as well, with architecture and engineering to construct the buildings in a more resilient manner. I think that's my view here. I don't know, Joel, do you want to put your point of view on that, and then Jerome, then we have to, I guess, wrap up because we're already on top of the hour.
Yeah, definitely. I will try to wrap up real quick here. I think what we have done in Link.io is take it from two sides. We have started to develop our own tools for very specific tasks as well, and using a different set of tools and software that have already leverage AI to help us to do work, either if it's floor plan generation or optimization in LCA, for example, or image generation, of course. So I think going back to the question, what we have seen maybe in the last 2 years is the pop-up of a lot of ideas and sort of initiatives on AI, and of course in different levels of development. And right now I think we are in the consolidation of AI. So from our experience, we have seen that there are not so many tools popping up as 1 year ago, but right now the ones that have really learned into to make sense of all the data they are receiving. For example, most of the tools that we have used, they not only receive a prompt, but they are trained with our own custom data. And then it really makes sense for us to use, for example, our old floor plans to help us to generate our set of floor plans with previous knowledge and experience that has been gathered, right? So I think in the coming months, I hope that the consolidation of these AI tools will continue. And I think this is the step that we're going into. So far, for example, floor plan generation can help you in early phase, but it doesn't go all the way. And it really still is lacking some of the qualities that we would like to see already embedded with the data that we provided with. So I think we're entering this consolidation of AI services and knowledge. And hopefully we can get again to the point that you mentioned, Richard, consolidated tools that are helping us on a specific task for our daily work.
Yeah, I think I agree with all the above. Let's say, I mean, I showed a few tools, let's say, right? So they really come down into, I think I see them as early stage tools, like generating options, that going through things quickly and much more ease, whether that is the single truss, the column, or in your case, the generating floor plans, let's say. And then on top of that, I think I haven't shown anything of that, but we're doing a couple of tests with really thinking about it as co-pilots, let's say, right? Like you see them popping up in your Outlook and Word already and that sort of things. But taking that a step further and really becoming like, we're doing a test now with a company called Glean. So they have a ChatGPT-like chatbot, but you can actually train it on your company's data. So it becomes a ChatGPT chatbot, but you can ask it like, oh, I need to design a football stadium for 80,000 people. Who in the firm should I talk to? Or which projects have we done, and can you dig me out the concrete details of that and that? That type of like talking, interacting with the tools, let's say. And you could see that as well. We're organizing every year. We're organizing in New York our AEC Tech event hackathon, and you could see a couple of hacks of that coming through, where start to talk to your models in a way, right? Like it's it becomes much more intuitive to work with these complex topics, complex models, but then also pull information back out and bring that to the next level. I think that's what we're going to see a lot of. I think and I hope. But yeah, we'll
Perfect.
see. 18 months is long in this world.
Yeah, great. I'll book a date already for the next webinar in 18 months.
All right,
and then
that's the date.
Kind of catch up on our predictions here. Yeah, thanks.
Yes.
Thanks a ton to both of you. It was really insightful. I again learned a lot today. Really very interesting. The time flew by. Yeah, thanks for your efforts. Thanks for having you here and joining the webinar. And yeah, thanks to the attendees. We tried to at least conceptually answer the questions. Of course, we couldn't answer all the individual ones. But yeah, hope to still see you next time. Maybe there's then also time where we can answer individual questions again. Thank you, and yeah, see you for the next webinar on SimScale. And yeah, until then, great time.
Great. Thank you.
Bye-bye.
Thank you. Bye-bye.
Yeah.